All right, IM2 classes. Today we are talking about triangle inequalities. Um, and there we go. Triangle inequalities and actually isosceles triangles. I need to change this type of card. We're also talking about uh, isosceles. Isosceles triangles. So two topics. So let's get right into it today. The triangle inequality theorem. So if you think about this one, it should make sense to you. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. So we look at this, if we add A and B together, that has to be longer than uh, the leg C, side C. If we add B and C together, that has to be longer than side A. And if we do A and C together, that has to be longer than side B. And really, if you think about it, if the two sides are not bigger, if you add them together and they're not bigger than the third side, then it can't make a triangle. If they're equal, it would just be a straight line. They need to be bigger so that they can like hinge up here to make a triangle. And if they're less than, they won't come together. So if you think about it, it should make sense. Um, Basically, what we're going to be doing is looking at the side lengths of triangles and determining if those side lengths are able, is that going to go up for me? Are able to make um, a triangle. What you need to do, basically, you need to take the two smaller sides, add them together, and see if it's bigger than the third side. So this one, um, we have two smaller sides. We have 7 and 7 and 2. So this is an isosceles triangle. We're going to get there in a second. But the isosceles triangle, so if we do 7 plus 2, is that bigger than just the other 7? So 7 plus 2 is 9. That is bigger, right? So this is this is good. Good. That one works. This one here, if we just look at the two smaller sides, we don't need to check all of them, just the two smaller sides. If we do 1 plus 9, is that bigger than 10? Well, 1 plus 9 is 10. Is that bigger than 10, right? Is 10 bigger than 10? No, they are equal. So this one does not make, since the two smaller sides added together is not bigger than the third side, can't make a triangle with that. Think the sides are just going to come together. By the time they touch, it'll be a straight line on top. So we're not able to make a triangle. Um, the other way to where I had no, I guess I don't. What we're going to do, the other part of the triangle inequality is listing the order of the sides. Like we're going to be given the side lengths, right? 12, 24, 25. We want to order the angles from smallest to largest. So we are now looking at the angles in here. What are the smallest angles in here? So which one's the biggest, smallest? How you can do that is, again, something if you think about should make a lot of sense. The smallest angle is going to be across from the smallest side. Medium angle is going to be across from the medium side. The largest angle is going to be across from the largest side. So here, we order it. We get yeah, black small. Yeah, I'm going to do green. Here we have our smallest side, right? 12 is the smallest. So that means angle K is the smallest, right? Because that's the angle across from it. The next smallest, we'll just go in order. We'll go red, right? There's the medium, right? That's the medium sides. Need, right? Angle across from it is J. So angle J then is the medium size angle. And then the last one there, you can see 25 is the largest So across from 25 is L. So angle L is the largest. All right. Wow, I made a mess of that, but that's okay. So let's go the opposite way. Now we're going to list the side lengths, all right, from smallest to biggest. So smallest side. So we find the smallest angle, 32. The smallest side is across from it. That is JK. So JK is the smallest. Small X. That's a weird way to smallest. Okay, whatever. You know what it's supposed to say. 49 degrees, that's the medium one, right? So across from that is going to be the medium, right? So that's side KL. And then we have the 99 is the biggest, right? The side across from it is JL. So that's all we're doing is just listing, not JK, JL. Listing the angles and whatnot across from each other in order from smallest to biggest. All right. So that's the largest. Did it right that time. All right. Let's talk about some special types of triangles. Equilateral triangles, where all sides are equal. Isosceles triangles, there's with two sides are equal. Or there are scalene triangles where there are no sides that are equal. We're going to be focusing on the isosceles triangle today. So isosceles triangle has at least two. So we will be dealing with some equilateral triangles because equilateral triangles do have two sides that are equal. So a lot of the same properties are true for equilateral triangles that are for isosceles triangles. So isosceles, it just has two equal sides. And then if we were to classify triangles by their angle, so acute triangle, all three angles are less than 90. Right triangle has 190-degree angle, and obtuse has one angle greater than 90. We're not going to be focusing so much on those today. We are dealing with these isosceles triangles today. Just a little bit more specifics about the isosceles triangle. The side that is not equal, we call this the base down here. This is the base of the isosceles triangle. And then these angles here, we call those base angles. They are congruent. So not only are the sides congruent, the base angles are also congruent. All right. Yeah, so that's what we get with the isosceles triangles. So let's look at some examples. Find the indicated side or angle. So sometimes it might be looking like, oh, this 10 is the base, but you gotta look, here are the base angles. So the base is here, right, on this side. So it means these sides are equal. So the X is just 10, all right? So the base isn't always on the bottom. That's one thing that kids get confused about for some reason. The base is the side that is not equal. We know these sides are equal because of the base angles that are equal there. Looking at here, this one is a little bit more complicated. So we have here, this is 70 degrees. This is the other base angle. This is right here is the base of this isosceles triangle. Those base angles are congruent. So that means this is 70 degrees. All right, we need to find X. So we need to use that triangle, the angle sum theorem we learned last time, where if we add up the angles of the triangle, they add up to 180. So 70 plus 70 is 40. That third angle is 180. So if we subtract 180 from both sides, my plus, so that look like two X's there. Subtract 140 from both sides. So that'll cancel out. You get X is equal to 40 degrees. So sometimes you're going to need to combine some of your knowledge of isosceles triangles, those angles being congruent, and the fact that all three angles in any triangle add up to 180. Next example here, find the value of X. Again, now we're just going to set up an equation. So we have our base angles here. So this side is the base, right? That means these sides are congruent to each other. So it's just when things are congruent, you set it equal to each other and then solve. So 2x minus 14, you add 14 to both sides. That cancels out. You get 2x is equal to 24. Divide by 2. And you get x is equal to 12. I should put in a line of separation. So x is equal to 12. That's it. Okay, why don't we do one more? Angle 2. So this 2 is not the angle measure, doesn't have the degree symbol. So angle 2 is x plus 49. This angle is 41. So you got to remember, so we have the congruent sides here. That means this is the base over here. These angles are congruent, right? So angle 2 is x plus 49. That is equal to 41. Not 49. That doesn't make sense. Subtract 49 from both sides to solve. And you get, it is going to come out to be a negative. That's okay for this one. X is equal to -8. Done with that. And I think that might be it. Let's see. Oh, no, we have one more. Okay. So angle 2 is 20x. I'm actually just going to fill it in here. Angle 2 is 20x. Again, these two sides are congruent. So that means this long side here is the base. And that means that these base angles are congruent, right? And then what that means is that this angle here is also 30 degrees. And so now we're going to use that triangle sum theorem to find x. We just add up all the angles, 30 plus 20x. They all have to add up to 180. All right, so from here, not yet. Combine like terms, 30 plus 30 is 60. Plus 20x is equal to 180. I'm going to subtract 60 from both sides. So you get 60 minus 60. Cancels out. You get 20x is equal to 120. And then divide by 20. You get x is equal to 6. And now I think that'll do. I think that's it. Yeah, that's it. So that'll do it for this lesson today. Next time we're going to be talking about angle, triangle bisectors, medians, and mid segments. Tons of fun. See you next time.